was
Hard to find.
very hard to find.
Indeed. I
Put
told,
us off in the corner.
yeah, I told Jean-Marc earlier, you just keep going, and then when you think you've gone too far, you keep going.
Yeah, and I turned around and I went back to look at the map because this can't be right. After I passed the IAB, I was like, they're not going to put us after the IAB rooms. I turned around, went all the way back to the map, and keep going. Sorry about that.
Yeah.
So that you need to define new things. And I think for many of them,
Your slides.
what I'm not sure is when you do this family tree and dishonest on, you need to actually transfer the matrix. How much stuff can you meaningfully put into SVP before things merge?
If you're talking about RDC, probably there's not a lot necessary. I mean, if you're doing it in SIP, not much. If you're doing it, but in WebRTC, you can do enormous amounts. People put all kinds of, multi tens of kilobytes SVP is pretty common. How big is this matrix?
So it depends on the MSI's order. And what you transmit is, hold on, so for order 3, and the sonics, you end up with a 16 by 16 matrix. So 256.
So how many, each element is what size?
Let's say like each element is an integer. Let's say in August like a 16-bit integer.
Okay. Yeah, I mean, putting that SVP is not big. I mean,
No.
it's big, but it's not.
Could you go
It's like-
to like order 4 or like order 5?
Well, they go up exponentially, right? So,
It goes to order plus 1 raised to the power 4.
right.
Oh, so it's.
Yeah.
So if you do 5th order, it means 36 squared, right?
Yeah.
I mean, that sounds big.
It would be
But,
like 1,000 elements.
Of 2 bytes each.
I mean, it'd probably be a. I mean, it's a text format, so you'd have to spell out each integer.
Yeah.
Well, each integer would be like 4 bytes plus a comma, so 5.
Yeah.
Probably.
Like 5 kilobytes.
I mean, it would be a short request with SVP parsers. It would probably.
Okay, well, in that case, you may be able to.
Yeah. Get started.
Standardized voice over SVP. Most of them. I mean,
We do. Sometimes people do want to put video parameter sets in SVP. I think we've mostly talked about that. Like the.
Video parameter set's only a few
Yeah,
bytes.
like 864 parameter sets can be put in SVP. But that's,
Yeah.
I think the problem with that kind of resolutions. It reminds me of the Hennings's tall stacks. And there was a Hennings's tall stacks presentation, which was the challenge was how tall a particle stack can you make with the only particle that reads IP. I think he meant his winner was I think the DTMF RGB format is rich enough to express 300 baud modem. So the RGB, the DTMF payload format for RGB is actually arbitrary telephone tones.
Yep.
And it's rich enough to express a 300 baud modem.
So you can do modem over.
So modem over RGB. Express symbolically.
All right. Well, we're going to get started.
All right, this is the room where the two slides are a slight angle to speed of slight angle to each other.
Yeah, it's because the transcription, they run the transcription on one and not on the other.
No, it's
Oh, the angle?
yeah, the angle. The bottom is like it's either like a sort of like a 10-degree or a 170-degree angle at the bottom there. It's probably just that the paintbrush white line. Don't worry about it.
Been going all week like that, and then now you fixed it.
The things that bug Jonathan. Okay. Welcome everyone to IETF 124 MLCODEC session. We have a new note well, but it's the same content as before. Please review both the professional conduct expectations and the intellectual property disclosure expectations. By participating in any IETF activity such as this meeting, you've already agreed to all of those policies. So please familiarize yourself with the details of those policies. You got control? Yeah. For people in the room, please use the on-site tool. If you end up using the full client tool, please keep your audio and video off so we don't have any echo in the room. But please at least either join through Meet Echo or use the QR code in the room to make sure that we capture everybody that's participating. And remote people also, please keep your audio and video muted unless you're speaking in the mic queue or presenting. There's the agenda and Meet Echo technical information if you need help. And the session details are in the agenda. Notes link is right there. Do we have a note taker that can help? And you can only take very brief, final decision notes because we have a very good automatic tool now to get the play-by-play notes. So just capturing the very high level decision points. You have a volunteer for just capturing the high level decision points in the notes? Thank you, Jonathan, for the umpteenth time. Okay, our agenda today, we'll go over a draft status from the chairs, and then we'll be talking about the updates to the extension mechanism, followed by the updates to DREAD, and then the speech coding enhancements, quality extension, and then the intelligibility and testing of DREAD. And although that final one relates to DREAD, I know there was a request to see if we could put them back to back, but we wanted to make sure that we covered all of the work group items first. So that's why it's at the very end, because it's not a work group item.
Well, they're all working group items, so DREAD could be at the end. And that's gonna be-
Would you rather do it that way?
Yeah.
Okay, so we'll do Tim first with the extensions, and then hopefully is Jan in the spice? Okay, great. So Jan, if you don't mind going right after Tim.
Yeah, no problem.
Great. All right, so let's do that. No problem. So quick update from the chair side. We have a work group last call that ended on the extensions draft. Some comments received, and Tim, I believe you just updated the draft this week. So I think we'll expect another work group last call to run on that new update. But we hope to finish out that draft very soon. The redundancy draft, Jean-Marc has mentioned that he wants to finalize it fairly soon as well, but we just have another major update. So we'll see after that presentation what the status is of that, whether or not we're getting close to last calling that. Speech coding enhancements, I'll let Jan address the current status when we get there. But I don't believe we're close to last calling that. Scalable quality extension was just recently adopted. So we have a working group draft of that available now that Jean-Marc's going to present. And we'll decide at the end of that session, we'll decide at the very end of the session which ones we think are close enough to last calling. All right, so Tim.
All right, so Mo started giving my presentation for me, which is not a complaint. But go ahead and hit the next slide. Yeah, so I published a new version yesterday. Hopefully that addresses all of the comments from working group last call. Thank you, especially to Roman for making several good suggestions. Probably the biggest change is there's a new example section. So I don't think there's a lot of surprises in it, and is that it's mostly based on my mail to the list from last year. But there are lots of nitty gritty details. So if people could take a look at that and see if it makes sense, I'd appreciate that. And other than that, there's nothing new on this draft. So I guess Mo already said the next steps are we're expecting another working group last call soon.
Thank you, Tim. And it would be great if we could get some more reviews. So this extension mechanism is going to, probably outlive all of the other actual extensions. So we need to make sure that we're not missing anything important here. If we could get any more reviews of that draft, it would really, really help.
All right, thank you.
Jonathan Lennox, speaking somewhat as a chair of the ABTQR working group, do we want to tell what the multi-channel Opus people doing the payload in ABTQR that they should support this format? Or I guess it just happens automatically, right?
If you don't mind, go to the mic,
Yeah.
Jean-Marc.
Sorry, Jean-Marc Vanin. So your question is whether multi-channel Opus and AVT Core should do something specific about the extension?
Yeah. I mean, I think mainly that they should copy whatever we do for the SDP here and do that for multi-channel also. It's the main thing, I think, because the extension itself should just work with the padding, whether you're multi-channel or not. But I think they should probably copy the SDP parts.
Oh, right, yes.
Yeah.
Yeah, so yeah, I think anything that's done with multi-channel that copies the RTP indeed should copy everything that gets added to RTP from like different drafts, which is going to be interesting. I don't know how we track that, but yes.
So Jonathan, do you want something sent to the AVT core list about this work, and that anything that's copying things from Opus should also copy these extensions? Well, certainly a lot of them would not be in scope for multi-channel Opus, but the mechanism, yes, yeah, I agree.
But actually, now that this question gets raised, like, and I don't know if we already have that, but we should say that this draft updates the not only the Opus draft, but also the Opus RTP draft.
Yes, I think it would update both. Actually, does the extensions draft itself update Opus itself, or just the RTP? Clearly, some of the other extensions do update Opus, but does the extension mechanism itself update Opus? I don't think so.
Yes, the extension mechanism itself updates Opus because the Opus
interpretation of padding.
Yes, the original Opus says the encoder must set to 0 and the decoder must ignore.
Okay.
And now we're saying
don't
may
ignore.
not set to 0 and will not ignore.
Okay, that's good. So let's make sure that we, for the Shepherd write-up, we'll make sure that it's noted that this is updating both.
Yeah, just to be clear, the draft right now updates the media type registration, because I believe what it actually does is it defines the new SDP parameters as media type parameters, which then get pulled in that way. So I'm not sure the multi-channel Opus even needs to do anything special if it's using the same Opus media type. But that's not at all clear from the current multi-channel draft. So
It's using something called multi-opus, I believe.
I mean, I think it would make sense to have a link to say that it updates the RTP because, especially because of the issue that Jonathan raised about multi-opus, if we say that they should carry over everything that you do with Opus and RTP, then that would be like the easy way to carry things over, because otherwise they would never find out about this thing.
Okay, Jan, go ahead.
Mm,
Tim, are you
yes.
still in queue, Tim, for something?
oh no, sorry, I was in queue to make that comment.
Yes. Yeah, hi. I want to give a brief update on the speech coding enhancement, a bit about the bandwidth extension that I talked about last time, and now right on cue, also some considerations for SDP. Next slide, please. So on the algorithmic side, there has been some tuning of the bandwidth extension algorithm. There's a new model, roughly the same performance, but 60% quantized, which means 50% size reduction and also similar speed up. So there are also some standard C transcendental functions have been replaced by approximations, which only affected LSBs. There is more room for improvement, but I did an evaluation of the current state. And these are some numbers on Raspberry Pi 3, 4, and 5. At the moment, it's still closer, I think, to no lace than to lace. So some future improvements would be nice, and it's definitely possible. But this is now the state as is. So, okay. Next slide then, please. I also started talking about requirements for evaluating extending enhancement methods. And last time I basically proposed a bandwidth extension should not be worse than doing nothing. So basically a comparison against the original. I looked a bit closer into this and I've seen a few failure cases like below 10%, but still. So Opus itself failed on multiple items, hybrid mode, and also the blind bandwidth extension. And the worst part of it, it never pointed to actual degradation of the high band. So I still need to iterate a bit on that. And I expect to have an update at next IETF. Next slide, please. But one thing to start thinking about at this point is SDP signaling. First question, why we actually need signaling. I mean, it's like for real-time communication, you want to make best use of the bandwidth that you have available. And you have multiple considerations like bitrate, packet loss, redundancy. How do you want to split those things? And if you have an enhanced decoder, same as having a different codec, it kind of changes your equation. So for instance, if you would know that you already have a decoder, no lace running on the decoding side, you might be fine with sending less bitrate, knowing that it gets the same quality, or spend more on redundancy. So that means that the kind of enhancement that's applied on the decoder, that's relevant information for the encoder to make optimal decisions. That's the basic motivation to update it. Next slide, please. Now the question what to signal is at the moment. So the attempt is still to have a very generic setting where you don't specify the enhancement method itself. So we wouldn't want to say we use lace or no lace. And so this is an attempt to have few generic parameters that describe what the decoder is doing. One thing that's certainly interesting is the enhancement strength, just for and improving the wideband signal. And I mean, usually when you go from one codec generation to the next one, people make a rough estimate on how much it reduces the bit rate, usually leading like we have a 50% saving or 30% saving, something in this range. And basically one way to go would be to pick a reference point, let's say 12 kilobits per second, 20 millisecond frames, complexity 10 as an encoder setting. That point is, so to say, not the very best quality, but also not the worst quality. So it's somewhere in the middle. And then you can define the strengths by how much you can reduce the bit rate and still get the same quality as a rough approximation. And so this formula basically scales it to 0, 100, where 0 means you have no improvement at all, and 100 means you can get the same quality with 6 kilobits per second that you would get with at 12 kilobits per second with legacy Opus. So basically the best you can get, because that's the lower bitrate minute. So for lays from the listening test that we conducted, you would infer that its lays gives basically around 9.5. At 9.5 kilobits per second, you can get the same quality, and for no lays, it's 8. So that would be a way to describe the enhancement strength. And then to signal whether you can actually blindly extend the bandwidth, you could just specify the frequency until which you want to extend the whole thing. Yes, next slide, please. And so the proposal would be to add 2 new optional parameters to the audio opus media subtype. I'm very open for the suggestion of better names, but I call them OSCE wideband enhancement strengths and OSCE wideband bandwidth extension hertz. And 2 examples. So for if you want to run no lays with the bandwidth extension, then the line would, so you have this format parameter 96 corresponds to opus. And then no lays would have a OSCE wideband enhancement strength of 67, or actually 66 and 2/3. And it would extend to 20 kilohertz. And if you run lays without extension, you would set the strength to 40, and you could omit the extending parameter. One very convenient feature of this definition of the strengths, and that's coincidental because 12 is 2 times 6, is that if you divide the strength by 2, it gives you the bitrate saving at 12 kilobits per second in percent. So that makes it handy to use. Okay, next slide. Oh, yes, please.
Mo's an individual. Are the hertz truly just free form everything, or do you expect there's really only a few, like an enum of a few values that are relevant?
In practice, likely just a few values, but I mean, you could, for instance, decide that you just want to go to 12 kilohertz or 16 or whatever. So, I mean, for instance, 20 kilohertz here, that's an arbitrary decision by running a low pass filter at 20 because you say the rest is not relevant. So I could have also set it to 19 or 1953 or so.
Yeah, my general inclination is if you expect the algorithm to only operate on a few, enum values, maybe that's better to do than leave it open-ended with an arbitrary hertz. And
Okay.
and then and also, I mean, realize that we're talking about very low bitrate audio here. So SDP, being 100 times bigger than the next 10 seconds of your audio would be a bad thing. So let's try to be as, use brevity as a guide for all of the parameters in SDP.
Yeah, I'm sure it's no problem. I mean, we can specify semi-super wideband, or full band. That would be just 3.
Jean-Marc?
Yeah, Jean-Marc Vanin. I was just saying, like, maybe the parameters could also be like, enhancement, bandwidth and extension, yes, no. Like, I'm not even sure we need to specify. I don't know what the application would be, but it's another possibility.
Greg Maxwell as an individual. That was also what I was thinking. I think you want to think in terms of what you want the encoder to do. Is the encoder going to behave differently if it knows that you're going to super wideband versus wideband, or what level? And if it doesn't, then yes, no is what you want. If the encoder is going to do something different based on what it knows you're extending to, then you want to know that.
Yeah, I mean, I can hardly answer this. I mean, for instance, if you want to deliver full band quality and you know the receiver side is just going to do, I don't know, semi super wideband 12 kilohertz, then you might decide, oh, I spend more bits and I do full band. So no idea, but I mean, someone could have this idea, but
I think the real question may be like, do we envision having a bandwidth extender that doesn't go to 20 for whatever reason and only does 12 in the encoder, saying, you know, that's not enough for me.
maybe 16. I mean, you might be able to save a significant amount of complexity if you just do 16.
Yeah, okay. Then we might want to have just like a few super wideband and full band or something. Although 20 and 32 is two different super wideband. I don't know.
I guess
I mean,
an
one,
issue,
yes.
I guess an issue you might encounter with that is you don't know what the decoder is going to decode to in any case. So you can send full band audio, but the decoder might be putting out narrowband in any case, and you don't know that. So
True. Yes. I mean, I would be fine with either way. Okay, if there are no more questions, the next slide, please. So the question is so the next steps, it's basically, I will continue iterating on the requirements. I think, yeah, probably already close to something working, but not quite there. So I try to fix this up until next meeting. I mean, I will update the draft with the SDP updates. There is still the question what to do with test data. So far I've been using this years data set that is Creative Commons attribution non-commercial. I actually got already the proposal just to reach out to the people whether we could get it with a different license. And then, I mean, in the end, the question is where to host test data. That's all from me this time. Thanks.
thank you.
If you can drive it, that's probably best.
Yeah.
Okay, so this is this mic on? Yeah.
We can hear you on the remote, so it must be.
Okay.
Okay. So this is the scalable quality extension for Opus, also known as Opus HD. Next slide, please. So a quick summary of what this is. Opus HD is there to lift some of the limits of the original Opus bitstream. So being able to support more than 8 bits of depth in each particular band, support for more than 20 kilohertz of bandwidth, and going above 500 kilobits per second per channel. Scaling up to 500 kilobits per second per channel. And the idea is to do this with full forward and backward compatibility with RFC 6716, so the original Opus. Next slide. So what's changed since the last IETF? In terms of code, it's been mostly and surprisingly stable. There's been no significant decoder changes. The previous test vectors that I presented at last IETF are still working with the current one. Aside from very minor bug fixes, there's been some encoder tuning and fixes. But again, the format remained the same, and there's not really any further changes that are planned unless like any issue is found with the current proposal. So the draft was recently adopted as a working group item. um, Jonathan?
Yeah, Jonathan Lennox. I was just looking. I don't see any SDP negotiation in the draft.
Indeed.
I feel like we should have that.
Yeah, the focus has been so far like really on the
Okay.
bitstream itself.
Okay.
I
mean, I guess no further changes planned to the bitstream, not to the draft.
No, to the bitstream. I
Okay.
mean, yes.
Okay.
Not to the draft. Still needs more work, but I'd be curious what you think we should be doing. Like this is not something that I even considered yet, so I don't know if
I mean,
you
I
have
would
ideas.
think that it would be, you'd want something analogous to the things we have for regular Opus that, I'm only planning to play out to, I can only usefully play out to this frequency, so don't bother sending me more than that. Basically, it's the receiver side and sender side. How far out is it actually useful to go? Or how far out are you planning to go on each of these dimensions?
Yeah, so the existing RTP draft already has all of these things for the regular Opus. So I'm thinking like, to what extent does it make sense to reuse the same parameters or create new ones?
I feel like you don't want to deeply confuse something that doesn't know about this extension. So
like the original one, for example, has like a bit rate. Like, please send me this kind of bit rate. So should we suddenly start using?
Yeah, I mean, I think the bit rate, the bit rate probably needs to incorporate the extensions, but things like what's the frequency range you're sending? I think I suspect a lot of things would be very surprised if you said put 96,000 there. So
actually, I guess the original also RTP has Opus 48,000.
right. Well, I mean,
which is going to be compatible if
yeah,
even if you put
90.
90s.
No, but I mean, but there's also the parameter that says my speakers will only play out up to this frequency range, and that the standard parameters probably should not go beyond what the initial spec says, and then they should have extensions that say, by the way,
initial one never put an upper bound, so I don't know if it. But maybe someone said
it
like
never explicitly put an upper bound, but I've had a lot of things assume 48.
Yeah, okay. So you would put like new parameters.
Yeah.
I'll think about that. Thanks. Yeah, so also as a result of the draft being adopted, the code is also now landed in the main branch. So if you get Opus from the main branch of the repository, you compile, you enable, it's called enable QEXT, and you will get this, so please test it. And last thing, as of maybe 2 hours ago, there's an IPR declaration from Google that was filed. I've been told it's free, should be fine, but I've not even myself been able to look at it. But it should appear on the IETF site shortly, I assume.
So I would encourage everyone to please review the details of the IPR filings and make sure that that your support of this work doesn't change by anything that's filed.
So next slide, please. So in terms of conformance, this is a reminder of what I presented last time. There's test vector material that I've created. They're still working. It's 96 kilohertz audio and floating point format. It's got 3 synthetic clips with sine wave, noise, and pulses, 2 music clips, 1 speech clip. Interestingly, it's all been synthetically extended to 96K using Jan's methods for speech, but good enough for music as well. There's a strict decoder conformance test with the compare tool. The encoder side is not normative, but we have like this an optional test for the encoder. Next slide, please. So in terms of the status, again, not very much changes. It's all running code. It's landed in main in the GitLab repo. There's a GitHub mirror as well. It achieves minus 115 dB THD plus noise at high bit rate. This is the link for the test vectors, the same one as last time. There's this QEXT compare tool. It's also in the main branch. And it's got a script as well, QXT test or something, that will run all the test vectors. And it's been calibrated so that the fixed point implementation also passes the test vectors. Next slide. So in terms of standardization, we propose that to do it sort of the same way as 6716, which means essentially like a text description of what we code. And in the end, the code is normative because the code also includes all the code from 6716. And all of that would be verified with test vectors and a compare tool, not the same one as the original Opus, but derives from that. From there, the questions are, like, again, where do we publish all of this data? And is there anything else that's missing? Now I know the RTP, but is there anything else?
Which data are you asking to publish?
Sorry, the data is, I mean, the stuff on top, like the essentially the code, the test vectors. Those would be the bigger ones, which, you know, for Opus, the code was, you know, base 64 encoded in the RFC, and the test vectors were, you know, from meeting proceedings. So hopefully we can do better this time.
It was never a good example, but maybe we're forced to do another bad example.
Well, I mean, I think we're going to have, Jonathan, I think we're going to have, I mean, it's not, we're going to have even worse problems trying to do that for Dread. So I think maybe we should figure out what we want to do for Dread, and then, you know, do this will be easier than Dread, so we could do this the same thing for Dread as for this.
Why are you saying that this will be easier than for Dread?
Smaller.
It may be bigger depending on what we do for Dread. Like
Well,
the test
the
vectors
vectors
are not small. It's
Those are 96 kilohertz.
Oh
floating
yeah,
point.
that's true. But the
and floating point
but
format.
the
So
training data.
I don't think we should do the training data for Dread, but we can discuss that in a later presentation.
Okay.
But bottom line is probably like a few tens of megabytes we're talking about here.
The other question I had.
It's a lot of pages.
Yeah, and the other question I had is, does this format extend to multi-channel Opus?
This would extend to multi-channel, yes.
Okay, so that would be applicable to the multi-Opus people.
Yes.
Okay.
Jonathan, do you need us to tell someone in ABT Core about that, or are you going to relay that?
Why don't you do it as the chair of the
Okay.
Okay, so this time deep redundancy for Opus or Dread. Jonathan, I think this was left over from last time, right? Okay, just checking. You're not disagreeing with my title. Next slide, please. So technical changes since the last IETF. There's been some training improvements, mostly as a result of the testing that's been done last time and shared, where there was some intelligibility issues that were raised. So I tried to improve that with changes to the loss function during the training. Mostly two things: adding a fourth power term to the loss, which essentially sorry. Essentially what that does is when you have very short phonemes with just the standard squared error, sometimes the encoder goes like, yeah, this is not really worth it for such short period of time. Let me just go over it and not code it very right. So fourth power improves that, and I think it improves intelligibility. We'll have the results in the next presentation. Also, the loss function also operates in the sort of so-called loudness domain, which is square root of the magnitude of the spectrum, which is less sensitive than log to like very small values close to 0. And with that, Greg and I have been doing dozens of full training runs with just like different random initialization. We each took the best model we were able to get based on that, and we had the folks at Cisco test that for quality and intelligibility, which is going to be the next presentation. But based on that, we selected a potentially final model that is now in the main branch. So if you've been using the main branch for Dread, the Dread model just changed. It hadn't changed for many months, but this one is new. So it won't be compatible, but please test it. So the new model is slightly smaller than what I presented the last IETF, which was already about 3 times smaller than what used to be in main last week. So the encoder is now down to 190,000 weights, 240,000 weights for the decoder. So that's just a bit more than 500 kilobytes for the complete models once quantized. And as I said, this is all in main. Next slide, please. So I've updated the test vectors, which are still the same URL, but it's different test vectors. And I've just realized that the test vectors I put in are based on a quantized version of the model. So I'll probably update them again to be based on the float, but that's still very close. And there's this dreadvectors.sh shell script in the main repo that can actually automatically run everything and compare. So in terms of what the test vectors cover, there's 3 sets of tests that get run by the script, and including the test vectors. The first one is dread decoding, and that is a normative test, and it's quite strict. The bounds on the output are quite strict there, because you need to do exactly this decoding, essentially. The second one is for the vocoder that goes with Dread. That one is meant to be replaced by better vocoders in the future. So it's still normative, but the test is designed to be quite loose so that any vocoder that, vaguely where the output vaguely resembles speech, that should pass. And there's also test vectors for the whole integration within Opus. And those are not normative because we expect things to change quite a bit, but they're there just to make sure that implementations are at least vaguely correct in terms of time alignment and so on. Next slide, please. Now, in terms of artifacts that we should have in the whatever we standardize, the ones that I believe are essential are the following 3. First, the model weights published as floating point values. That would be about 2 megabytes, which is 4 times the sizes I presented earlier because float is 4 times bigger. Then we have the test vectors, and the compressed test vectors are about 6 megabytes. And then there's the Dread compare tool with the FFT that's needed there. And we're talking about 1,200 lines of code. And that itself is sort of the minimum that's required to have a Dread specification, I believe. Next slide. So this is potentially useful stuff that an implementer might find useful, and we can decide which of that we want to include. First one is the Python model that actually that's the output of the PyTorch training. So that's also about 4 megabytes for all of the weights. this can be useful for, regenerating the models in a different format or quantizing them differently. That can be useful, but it's technically redundant with the first part. There's we could have the reference code for the vocoder and the weights. That's about 4 megabytes for all the code. There's the quantized weights file that is actually used in the current implementation. They're just derived again from the floating point. The complete C reference implementation, that would be essentially what you get if you download Opus from the main repo and fetch all the weights. That's about 10 to 36 megabytes, depending on whether you fetch the weights as float or quantized. There's a Python training scripts, not very big, but it's what generated these weights. Even though you cannot directly reproduce, you can know how it was trained. And there's a training data, and that one is like tens of gigabytes. But that is essentially the optional things we could have for convenience or not. Next slide. So now that everything is landed in main, I'd really like to ask people to just like test this new model, see if you can break it, see if it does something funny that it shouldn't do, if it works as well as the previous one, or if it works at all. I mean, it should work to some extent, but more testing is good. Testing dread in a real system also, that could provide very useful feedback. Like if you try it and see that for some particular use case, it's hard to use for whatever reason we haven't thought of, like we'd like to know about it before, before working group last call or IETF last call. You can also verify the training procedure. This is something that I've already done to some extent with Greg. If you'd like to, use the Python model, rerun training scripts on them, see that, they're not changing if you put them with the normal training procedure, like you can verify that I didn't do anything dodgy with these weights. And it's going to be a lot easier to check that now than to try and do it 5 years from now when you're at PyTorch version 5 or whatnot, that is completely incompatible. And also, please review the draft. Next slide, please. So these are essentially like questions right now. Where do we put these large artifacts? And is there anything else that we need to complete this work?
Okay, let me ask a question about the last question. What else? So at the previous meeting, you presented a pretty substantial update. Did you already know that you had another significant update in mind, or did you consider things mostly stable at that point?
Not sure. You mean with the
Previous
3x?
meeting when you did the big rev of the major quantization, and Dred changed a lot. Were you already aware that there was going to be, some further refinement? Basically, I'm wondering where we are today. You seem to think that we're close to being final. Did you think differently last meeting, or
last
did you
meeting
think the
was
same, and we're going to be in the same boat again, and there's going to be another significant change that may pop up in the next couple of months?
So last meeting, we knew the weights were not the final ones. We knew of a few things. Essentially, most of the changes compared to last time were as a result of this presentation by your Cisco colleagues about this intelligibility test, and that's sort of what got this current revision. So unless they come up with something completely new that I haven't seen in their last test, I still think we're good.
Okay, and then can we back up 2 slides to the artifacts themselves? This is the potentially useful ones. Okay, the essential ones, yeah, it's still too much for a for a hack like a base 64 and an RFC. So
No,
we're not,
that's
we're definitely not going to do that. So I don't know if Ori has any kind of guidance about, is there a permanent archival place that we can normatively reference?
Hi, Ori Steele, your responsible area director. I know that IANA hosts Yang modules that can get kind of long. I think it would be worth a conversation with IANA about this particular problem space, just to sort of see what they have to say. I mean, then off the top of my head, we do, when we publish RFCs, at the time of publication, we expect all references to sort of be resolvable. We click links. And then over time, that isn't always necessarily guaranteed to be preserved. But I think that's also a valid option. And then my recommendation for that would be sort of pick the place that you think is going to be able to hold this size artifact for a long enough time for its usefulness, I guess. You mentioned that there was this issue with PyTorch where future PyTorch versions might not be able to, I don't know, reproduce the results you have now. What is the lifetime for these artifacts? Like, how many years do you feel like they'll be useful?
I mean, these ones, they don't depend on PyTorch,
Okay.
so that's not an issue there. But I mean, the life is the life of Opus, like essentially like forever. Like if you want to support this thing, you need it.
Yeah. I know it's normative, but like, how many years?
Before there's a Dread 2 or something.
Right.
I mean, even then, people are still going to have this.
All right,
But it's more than 10 years.
Like
Like
the normative part, yeah.
Yeah,
Probably.
let's talk to IANA. I think the IANA would be a good next step, and I can do that, or I can set up a chat with all of us. But I'll go, grab them at the booth and get a first pass, and I can come back to you. And if I don't, ping me.
That sounds great. Yeah, that's very.
I mean,
welcome.
to some extent, I don't expect people to actually download these. Most people will never need to download that because they will download the actual implementation.
This is more for reference than
Yes.
for development use.
Why do you need to include them as reference at all then, if no one's going to use them as part of an implementation?
I mean, for example,
the implementers need them.
Well, the implementers probably, if the implementers care, they would verify that what's referenced in the spec actually matches where they're actually downloading from, where they're probably going to actually download from some mirror that is not the archival space of IETF. Probably it's probably going to live in some, like where's libopus hosted today?
Zip.org stuff. Yeah.
Where's lib
site? Yeah.
So another thing you could consider is, just, record the hashes of them, publish the hashes and say, obtain, this
By whatever
from,
means
by whatever
necessary.
means necessary. These are the hashes we had at that time. Exactly right. Yeah.
By hash collision algorithms.
Don't use
obtain
MD5.
this.
Yeah. You shot 512 or something. It'll be fine.
Okay. All right. Thanks, Ori. That would really help if you can square off with IAN and then let us know what comes of it. Okay, Laura, you're up.
Okay, nice. Hi, everyone. My name is Laura, and we have some updates to the test battery for the MLCODEC session. So maybe if we move to the next slide. So we have, as Jean-Marc already introduced, evaluated these new candidates for DREAD with the improvements that Jean-Marc described. I'll briefly go over quality, but then we'll dive a bit more into the intelligibility that has been more the focus of improvement. And just a quick note, so we've also updated the results for the baseline. So for the DRED version that is currently, or that was in main until the recent update, where we didn't use the Python implementation that we previously used on our side, but used the official implementation, and Jean-Marc kindly processed the stimuli for us so that there's continuity and there's no differences in implementation. Okay, next slide, please. So in clean, we saw, so within the columns, so to speak, on the left, we see the baseline, and then the two best candidates that Greg or Jean-Marc trained, and arranged by low, medium, and high average bitrate. So we tried to compare quantizer outputs that were approximately comparable. And we see that in clean for quality, we see mostly comparable, perhaps in the low and medium, slightly degraded versions. I mean, I can venture guesses, like, you know, it's a smaller model and so on. So maybe that was one of the compromises. But also I want to note that in the medium bitrate category, so for quantizer 6, the average bitrate is actually around 100 bits per second higher than for the two new candidates. So this maybe doesn't explain the entire difference, but it might make up some of that difference why we see a slightly larger drop. However, I think these are probably expected from what I heard from Jean-Marc, so not huge degradation generally, and at the benefit of a smaller model. If we move to the next slide.
Laura, real quick, just on that previous slide, just a reminder of what the low, medium, and high are. Is that roughly half 1K, 2K?
Yes, exactly. It's approximately 500 bits per second, 1000 bits per second, and 2000 bits per second, more or less. So 1700 more or less. So we tried to align it a bit with the 3 quality levels that we evaluated last time, but within the C implementation framework of V1.5.2 and then the new candidates. So one thing also to note, sorry, I briefly forgot. In the high quality range, we see very equal results here, but it might be worth noting that for the baseline, this is the highest quantizer available, whereas for the 2 new candidates, it's actually the first one down. So it's the second overall. So there's a little bit more room up, which might possibly, you know, gain a little bit more. So at the high bit rate, there might actually be an advantage for the new models that we don't see at the lower ones. So the goal was not necessarily, as far as I understand from Jean-Marc, to improve the quality, but to keep it relatively stable and improve intelligibility instead. Moving to the next slide, if there's no further questions. So this again is quality, but in real world speech and noise and reverberant speech. So this, just to remind everyone, is really is light noise and light reverb, and it's not these are not synthetic files. It's actually speech recorded in naturally occurring noise and speech in an actual reverberant environment. So here we see a bit of an odd pattern for medium bitrate again, potentially partially also due to the slight average bitrate discrepancy that I mentioned. So these are obviously the same models. So generally we see an advantage for the new models, which might be even higher in in the high bitrate category for the Q0 quantizer, so for the absolute maximum. But at comparable bitrate, we see a slight advantage, and the same in the low bitrate group. But for the medium bitrate group, the baseline DRED implementation is a bit ahead. So again, other than this slight bitrate discrepancy of about 100 bits per second, and perhaps a different distribution around the quantizers, I'm not sure I can explain this necessarily why. We don't see the same pattern. I don't know if Jean-Marc wants to venture guesses or if he has any observations.
It is almost a 10% difference in bit rate, so that could be it. But.
You're talking here about the medium one.
Yeah.
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 I think there's something a bit strange with that Q6 quantizer there to begin with. In general, my guess is just this tilt towards intelligibility and while shrinking the model, the two combined together.
Okay. And then we can move on to intelligibility. So we've tested intelligibility in clean conditions. And we see that basically in all the bitrate categories, we see an advantage for the new candidates. In the high bitrate, it's very small or very hard to measure. So for this, we would really need to run a test that is a bit more challenging. So we're kind of hitting a ceiling there where there's not that much discrimination between the three versions. We could either do that by corrupting the input signal, or corrupting the signal a bit by having challenging inputs, so maybe noisy or reverberant, or we could raise the intelligibility threshold by adding noise after processing with the codec. But for now, we have the clean results here. And I think the main point was to improve intelligibility in the lower bit rates where it was, a bit more degraded. So we see here it's around 80 for the baseline, and the improvements that were made push it now up to in the Jean-Marc's model up to around 85. So that's a great improvement. We can look at the next slide for some more detailed results. This is perhaps a little overwhelming and better processed offline in detail, but there's quite a few items, so it's not really just concentrated on one or two items in the baseline where there are some degradations compared to the clean results. So this is a delta plot where each numerical value, if it's negative, means the score for the tested version is worse than clean. Or if it's positive, then it's a slight improvement. But here, obviously, that is not the purpose to improve over clean. And we see that maybe the model that Greg picked is a bit more evened out. So this one very intensely negative value that was there, th and f, the confusion was th and f. So the ground truth was th. I hope you can hear the difference when I'm saying it. So voiceless th versus f. Yeah, the non-dental fricative, the alveolar fricative. So it's a bit more evened out, but Jean-Marc's as a total has more improvements in this case. So we're looking at the low bitrate here only because we see the largest gains there. So to make it a little bit more digestible, I took the difference also between the new candidates versus the baseline. So on the next slide, we can see that. So here, blue means it's an improvement over the baseline DREAD model, and red or pinkish is more slightly more degradation. So for this, there really is like it's interesting to look at what kinds of phonemes were improved. So markedly, for example, N to M, so N to M, P to K, K to P, G to D, D to G, and the to z. I hope any of this comes through. If not, please consult these tables after the meeting again. And these were items where there was quite a lot of degradation in the baseline. So they're all around 25 to up to 45 negative points over clean. So an improvement here of 39 plus, 33 plus, 20 plus is really a great improvement. Then in this plot, we also see a few degradations, but I think it's important also to note that, so I'm taking these examples from Jean-Marc's model on the right to really illustrate what we're looking at. So here there's a few numbers that are still like around 20 in the negative, but these really started off as really good in the baseline already, and then it's not actually degrading more or anything. It's just, I mean, it's degrading more, but a small amount that is maybe to be expected at such low bit rates. So not a big concern. So I think the one thing that maybe still in the previous plot looks quite red is this confusion between th and f. And this is really something that is incredibly sensitive in this test. It's probably the most sensitive test item. So I personally also wouldn't see this as extremely worrying. And the other items as well that are slightly negative, I think really to be expected at the low bit rates. So I think, yeah, some very good improvements were made.
Mo, one question as an individual. The data point at BD, that's +7 on the left and it's -17 on the right.
Mm-hmm.
Do you know what that is? What's that difference?
So that was in the original, it was -7. So Greg's model brings it to basically back to the same level as clean, whereas Jean-Marc slightly brings it down.
Okay.
Over clean. Does that make sense? Sorry, it's a lot of deltas, but. I know these are a lot to process. If people have questions also afterwards, please do contact me if you have questions and would like more explanations of these. There's a lot of information in there that is maybe hard to parse in a few minutes, but if there are no further questions, then I think this, or Jean-Marc maybe has a comment.
Jean-Marc Valin, I just had a question about the, so in the test, my understanding is you play sort of a word or two words and they differ by one phoneme, but for each of these pairs, how many actual recordings were there?
Mm-hmm. So the test, the diagnostic rhyme test, is a standardized test where you can find the test list in the ITU documents. And it's not primarily designed to be aggregated by phoneme. This is something that we find very useful, but by phoneme categories or like articulation categories, phonetic categories, really. And one audio stimulus is presented and then two written alternatives, and the listener decides which is the one I heard. And we have two. So for this test, we ran it with a subset of 2 speakers for the entire list, 1 male, 1 female speaker. And for each of these phonemes, for example, there's multiple words that contain this phoneme, so that they are aggregate scores.
But is it like more like 2 words or more like 200 or 2000? Just
So
getting an order of magnitude.
Yeah. So the whole test list is I think about 200 word pairs.
So for
100
each phoneme pair, that would be just like a handful or something.
Yes, from 2 speakers. Yeah, and they're not the same necessarily 2 speakers throughout the entire list, but there's always 1 male, 1 female speaker.
Okay. And you mentioned that the test is also meant to be presented in terms of, classes of phonemes. So maybe, do you have these graphs for that, or otherwise could you share them? I think that would be also interesting to reduce the amount of noise, because I feel like there's a little bit of noise also in there.
Yes, yeah, we don't have them in this slide deck, but we can definitely make them available for sure.
Thanks.
Yeah.
This is Rüdiger Geib, Deutsche Telekom. I happen to be active in IETF study group 12, and this is English then.
This is on English, yes. Currently, this is on English.
Yeah, that's not an issue, but it would be nice if you indicate that in the slides or so.
Yes, that is a very good point. Yeah, thank you.
1 male, 1 female, English. That's
Yes,
what they do in IETF.
Yeah, thank you.
No,
We actually we actually do have in our data repo where we host the data for this, the input data. We have I think 5 versions currently. So we have also German, French, Spanish. I'd have to check the exact.
American English, or were there other varieties of English?
It's predominantly American English. If there were British English speakers, they were only selected for word pairs where it doesn't matter, where there's no difference. Yeah.
Yes, Jonathan. I mean, I guess my big question is, what is your conclusion from this? Is this is good and we should do what Jean-Marc says, or something else?
I think our tests support a positive conclusion on what Jean-Marc set out to do. That is what I think it does. I mean, our main focus is to really bring the methodology, not to necessarily relate it too much to the models, and doesn't have to be limited really to DREAD, but yeah.
Kurt Durgeon here. I didn't see on the slides the original bit rate of the clean samples you were testing it against either. I didn't know if it mattered or not, but is it? Oh yeah, okay, all right. Clean is a massive sequence. Okay.
Sorry, I couldn't hear what Jean-Marc said, but
I said infinite bit rate, essentially not quantized.
Yeah. No losses or anything, no compression. Yeah.
I just wanted to also point out that when I was talking about this candidate final model, I'm talking about the JM26D in this slide, which seemed to me like slightly better in terms of intelligibility, slightly worse in terms of quality, but I thought intelligibility was the most useful thing to pick there, which is why I selected that, but I'm open to reverting.
Okay, I think in terms of slides, this was it from our side. Maybe we have a similar question regarding data hosting, if this is any of any interest. So we currently, we added the link to our repo where we host this data, where we used it for the low resource audio codec challenge. I mean, it will live there, but if it would be useful to put it also somewhere in the context of IETF, then that could be a point. And then maybe another question from our side, connecting to Jean-Marc's presentation, or the call for action from other people maybe as well. You mentioned in-system testing, so perhaps there are some specific criteria regarding the losses that maybe should be tested, or something like this, that would maybe be useful to know for us and maybe other people who would like to test this in system.
Jean-Marc Vanin, yeah, I just wanted to say, like, I really think this should be published somewhere by IETF. I don't know if it makes sense to keep it as a separate draft, or if this should be merged into the DREAD draft in terms of characterization, but I definitely would like to have it like officially published.
Hi, Ori Steele. So I'm not sure what the best way to publish this kind of result is, in terms of the RFC sort of format. We're really limited in, black and white text. But one thing that you can do is if your working group has a GitHub repository, a lot of working groups have pretty rich wiki experiences. They have full control over the presentation of all of the content in their IETF repositories within GitHub. So if that's the thing that you're interested in, I'm certainly happy to give you a number of examples for how to publish content in that format. It's all still covered by the Notewell, the IETF contributing agreements. I can share examples if that's of interest to the
So
group.
correct me if I'm wrong, Laura, but I think you mentioned you're more interested in standardizing the publishing the methodology because it helped Jean-Marc make a change, rather than the result of,
Yeah.
okay, the change was actually this much better, but you want to find a place whether we should publish this as an output of this working group or some other IETF venue, that the methodology should somehow live on and inform other work.
Yeah, because I think the methodology itself isn't necessarily limited to DREAD evaluation, right? Like this could equally be used, like particularly the intelligibility test, to maybe at one point test the bandwidth extension that Jan was talking about. So I think it's a resource that we would like to provide for testing extensively with human listening tests. But at the same time, obviously the results for these specific models should also be documented somewhere. But that doesn't necessarily have to be the same place.
Yeah, just to clarify, my original statement was about not the methodology, but really these results, because it will inform anyone who uses DREAD. This is the kind of thing you can expect. This is the kind of intelligibility you will get at these type of quantizers. This is the kind of error that can happen. So I think this is quite useful from a user's point of view. They're not going to care about what the methodology was, but they're going to care about what the impact is on intelligibility. So I think that part is useful.
There may be another point too, because the DREAD isn't completely normatively specified. And so this kind of comparison mechanism might be something that an implementer might want to do to gauge the quality of the non-normative parts of their implementation too. So that would be a reason to standardize or to specify in some way the approach that was used. And then what you're talking about, I think, would be just like some text inside the DREAD draft that says, under this procedure, we got these kind of results. And it doesn't necessarily need to be the pretty graphs. It can be a text description of what the graph said.
Okay, so I think I'm hearing that maybe this work may be interesting for this group to look at adopting as a deliverable, to publish something as some sort of, even if informational RFC, about both the methodology and specifically for the DREAD results, and whether that goes in the DREAD spec or whether it goes in somewhere else, we can figure out. But does that seem kind of what people are leaning to? That we would like to see this as output of this working group? Okay. Should we take an adoption call now? I think it's a little too early.
Yeah, I think we should take an adoption.
Okay, you want to run a show of hands?
Yeah.
So we'll take a quick show of hands to see if people want to go ahead and adopt this as a draft that becomes an output of this working group. So starting with what Laura was mentioning, the methodology itself. And then I think separately, we can ask about whether or not DREAD should include the output of this methodology in its final version to show these are the results of this version of DREAD on this methodology. Does that sound like the reasonable approach? And no object.
Just saying, when it comes to DREAD, I think there's two options. One is to have the results in a separate document. The other is to have the results in the DREAD document. I don't really have an opinion on either one. Maybe some people see like a good reason to do one or the other.
Hi, Ori Steele. I just, I checked the charter. All of your proposed milestones are sort of proposed standard. So I think if you want the methodology as an informational document, I would recommend I can either put a note in the charter saying, relating it, or I can help, recharter to add a new informational milestone. Or if you want to put the results for DREAD in the document and you want the methodology along with that to explain, maybe like it's kind of stacking your appendix, but it's kind of up to you guys how you want to handle that sort of thing. I'm open to whatever the options chairs want. I'm happy to support.
Great.
Jonathan, because I'm just concerned, I want to make sure that we're not gonna, if we're publishing the methodology as a separate document, that we're not gonna block DREAD on that publication if it's referencing it. So, but I guess it probably shouldn't because it would be just informational. But no.
Sorry, what was the question? Could someone repeat?
John Mark was asking, is there a preference from people about whether the results of your test should be documented inside of the DREAD document or in a separate spec? And Jonathan said no preference.
Mhm.
And so I think as an individual, I think it's more like an artifact. So wherever we decide to put the artifacts, I would consider putting the DREAD results in that and not into the DREAD spec itself. So if we have the archival location for the artifacts, it could just go along with the model weights. Here is the output, of the test using this methodology.
You're talking about an artifact that is referenced from the DREAD spec, right? Or an artifact that is referenced from a different spec, because it comes down to which doc contains it. I think Tim has an opinion. Maybe
Tim.
I was just going to say, if you have concerns about this being in a separate document blocking publication of DREAD, it seems like putting it in the DREAD spec itself will guarantee that it blocks the publication of DREAD. So.
Yeah, I think we could have a small separate doc or artifact that DREAD doesn't. Does DREAD actually directly reference all those other artifacts that you mentioned, including the non-essential artifacts? Does it already reference all those?
So right now it doesn't, but eventually it will have to reference everything, all the artifacts we publish. That's why we publish them.
The essential ones, yes, and we'll find an IETF archival home for those essential ones. The non-essential ones, are you planning to reference all of those in DREAD itself?
I mean, if anyone that, to me, any of them that would not be referenced in the draft, we might as well just leave on the asif.org site. There's the only reason we would put them on the IETF site is because the Dread RFC would reference it.
And you had some though that I think you had some that you weren't too sure of, like the Python PTH files. Like maybe that would get referenced, maybe not.
Yeah,
So-
I mean, that is already included in the Opus repository. So the only reason we would have it as a sort of official IETF artifact is so that the draft or our eventual RFC would reference that.
Well, I think let's take this as two separate items. So I think there's it's clear that the methodology is useful to people, and we want to see if that methodology should be a draft output of this working group, and then running that methodology and getting some results, whether that should go in something else or whether it should go in Dread. That's a separate question. Let's start off with a show of hands of whether we should adopt this methodology and end up publishing something, and we may need to have a charter update to do that. But having an informational RFC based on this methodology to guide not just Dread, but any other audio work. So folks, please go to the show of hands tool in Meet Echo and put your opinion in. Impressive drum roll. I think it's pretty clear consensus that there's no objections and 10 yeses, one no opinion. So I think, and that's out of 17. So I think we have pretty clear consensus that people would like to have this as a working group item, and we'll figure out the charter question ourselves. All right, so Laura, we'll go ahead and have you submit a working group version of this draft for the next meeting, and just keep it as this version for now, and identical to this version. And if you have any planned updates, inform the list.
Sounds good.
And on the second question of whether or not the output of this test run on Dread should be in Dread or should be in a separate document, I think Tim's point is good, that we don't want to hold up anything in Dread, and we don't want to down ref anything to something informational, and so we definitely don't want it in Laura's draft. So there's just the question of whether or not the methodology will be informational, right? So
results are always informational.
Yeah, but it would not be a separate informational draft. Yeah. Well, I mean, are your other things, your non-essential binaries are also informational, are they not? So I think wherever we decide to host those artifacts, I think it makes logical sense to have these results along with all those as an artifact, along with that whole list of non-essential artifacts. And if that's referenced in the Dread spec, I think that's fine. If all of them are not referenced in the Dread spec, I think that's also fine. Okay. So that brings us to the end of our session. Thank you, everyone, for giving us some time back. And I'm sorry, really quick, can I get a quick show of hands of who thinks that they may attend the next meeting in Shenzhen, China? Okay, so, all right, so it's, yeah, actually, let's do a show of, well, yeah, so if you're remote and you plan to actually be in person in Shenzhen, let's do a show of hands. Yeah, Greg, can you end the?
So the question is, who is going to be attend in person?
Yes.
not remote.
Who thinks they will attend in person in Shenzhen? Would we have enough people to run a physical meeting in Shenzhen? That's the question. And just a note, we cannot have a virtual meeting during the IETF meeting or within, I think, like 4 weeks before or after. So if not enough people are available to run the physical meeting in Shenzhen, then we'll probably want to have a virtual interim, a month or two before or after March of next year. So that's what we're really trying to get to is, will we have enough people to run the meeting in Shenzhen in March? So we'll do a quick show of hands of who may be available for that in-person meeting in March. Okay, we show about 5 yeses and 6 nos out of 18. So that's that'll need some thought. We'll need to decide, I guess, closer to a month or two before to make our plans. All right, well, thank you very much. We'll either see you in China or on the list. Will you be in China? No.
Our previous meeting, I got an advice from the State Department, encouraging me to not go to China.